In this video, we're going to use the unit circle to estimate the sine, cosine, and tangent of each arc of given length. Let's start with part A. We have an arc length of 0.8. So the first step is to draw an arc length of 0.8 in standard position. So we come over and we start at 0, and then we measure counterclockwise a distance of 0.8. So here we're at 0.5, and we want to stop before we get to 1. We want to stop at 0.8. So we have 0.8, and we call this a value of t. So t, the arc length, is equal to 0.8. Now, once we've measured out the arc length, we then need to determine the coordinates of the terminal point. So if we drop a vertical to the x-axis, we can see that the x-coordinate is approximately 0.7. And going across horizontally, y value also appears to be 0.7. So once we have the coordinates, we've got our x-coordinate and y-coordinate, we're ready to use our definitions. We have cosine of 0.8 is equal to the x-coordinate of the point, and the x-coordinate is 0.7. The sine of 0.8 is equal to the y-coordinate, which also about 0.7. And then to find the tangent of 0.8, we take the y-coordinate 0.7 and divide by the x-coordinate 0.7, and we come up with 1. Now these are just approximate by using the unit circle. If we want to get better approximations, we can use a scientific calculator. I'm going to go ahead and use Desmos. First of all, whatever calculator you're using, double check and make sure that it's in radian mode. So we'll enter cosine of 0.8, and notice that 0.6967, that rounds to 0.7. We can also find sine of 0.8, and it's a little bit more, but to the nearest tenth it rounds to 0.7. And if we find the tangent of 0.8, it rounds off to 1.0. So using the unit circle, we did pretty well. Let's go ahead and try part B. For part B, we have an arc length of 2.6. So again, we'll go to the unit circle. We'll start at 0. We'll measure counterclockwise until we get to 2.6. So here's 2.5. 2.6 would be right after that. So we've measured out an arc length of 2.6. We want to estimate the coordinates of that particular point. If we look down at the x-axis, we can see that the x-coordinate is approximately negative 0.85, I'm going to say. And for the y-coordinate, we look across at the y-axis, and it looks like it's somewhere between 0.5 and 0.6, so I'm going to estimate it to be 0.55. And then now we're ready to evaluate. We have cosine of 2.6 is approximately negative 0.85. The sine of 2.6 is approximately 0.55. And for the tangent of 2.6, we take the y-coordinate of the point, 0.55, and divide by the x-coordinate, negative 0.85, and that comes out to approximately negative 0.65. Pause the video and try part C on your own, and then we'll go through it together in just a moment. In part C, we have an arc length of 4.0, so we start at 1, 0, measure counterclockwise until we get to 4. We estimate the coordinates of that point. Looks like it's about negative 0.65, and the y-coordinate is approximately negative 0.75. So the cosine of 4 is approximately negative 0.65. The sine of 4.0 is approximately negative 0.75. And the tangent of 4.0 is approximately negative 0.75 divided by negative 0.65, and that comes out to approximately 1.15.